We're going to go ahead and get started for everyone. So those that are on their lunch break can take advantage of this live webinar. This is the next installment of Stormwater Live here on LinkedIn. My name's Ty Garmon. I'm the co-founder of Digital Stormwater and the host of the Stormwater World podcast. And with me today is Ms. Lohayne Schutzman. She's the lead engineer with Parjana Engineering, and she's going to walk us through the IRIS Infiltration System today. And I don't want to take up any more of her time. Lohayne's been doing this presentation for a long time. She's been with the company since, I believe, 2018, if that's correct. So she has a lot of information that she can share with us. I encourage everybody that attending, if you have questions, please put those questions into the comments. We have folks monitoring the comment section so we can get those questions answered. We will be doing a Q&A at the end, and so we'll get those questions answered. If they haven't been answered in the comments, we will get them answered at the end of the presentation. And if for some reason you need to drop off and you don't get your question answered, we will answer them in the comment section so you can come back to the page and get your question answered that way. So with that, Lohayne, thank you for taking the time today to present, and the floor is all yours.
Thank you. Thank you, Ty. Hello, everyone. Thank you for having us and giving us this opportunity to share a little bit more about our company and our product. So it's a pleasure to be here, and today I want to share a little bit more about Parjana Engineering. I'm going to tell you about IRIS Infiltration, our newest technology, how it works, and some details about this project. I'm going to cover a little bit about our site evaluation process that usually answers lots of questions about the product itself and the kind of information we need in order to provide our solutions. I also have in here a frequently asked questions built in. Those usually always come out, so we already anticipate them, and I have some good examples of our technology within those contexts. And the last thing I'm going to share is some possibilities and benefits with our product and open up for Q&A. So once again, thank you for having us, and now it's all about Parjana. So who we are and where we started. So Parjana Engineering started here in Detroit. The company started in 2012 to commercialize this product that had been installed since 1997. So ever since, like, our company has grown a lot. You can see that there's many regions of the United States where we have grown our market to. And the interesting thing about this that I always love sharing is that in all of these different regions of the United States, you can see that they will have like different weather patterns, different geology, different hydrology aspects, different like soil type. And it's very amazing that we got to install and test our technology in such like different environments, and we have observed that our product has been successful in all of them. So this has given us a great amount of like confidence in our product performance and adaptability in different contexts and different scenarios. So with that, we are confident when we are offering solutions and saying that we are able to help, even though we might not have covered that specific region or that specific type of project. This mix between all of these other products has definitely given us that confidence. So let's talk about it. How does IRIS infiltration work, and what are you guys really doing? So IRIS Infiltration is a product that we installed in the ground, and what I want you to take from this picture here is that our device is buried like 2 to 3 feet below the ground surface, so there's never any contact between the surface water and the head of the devices, but that facilitates water movement in the ground pretty much by connecting different soil layers. Another thing that I want you to take from this picture is that when we talk about iris infiltration, we are talking about a system. So we're talking about like dozens, hundreds of devices installed vertically into the soil that will work together to accomplish a certain goal or a certain criteria established by the client. So let's talk a little bit more about how this product works and what do I mean by connecting soil layer. So I have here in the screen an experiment that I have the source of the video here. I highly recommend it. It's very interesting. Most of the folks in dealing with stormwater are familiar with this, but it's always good to share. So water movement in the ground sometimes can be a little bit deceiving. So if you see this experiment here, they are beginning to saturate a layer of loam into the soil, and they have a layer of sand crossing that loam, so more pervious soil. So as they saturate it and as that waterfront gets closer to the sand, like our intuition is what's going to happen when that happens. So we think, well, water will get to the sand and then it's going to move laterally in the sand because sand is more permeable. But what we actually see is that water gets like pretty much held up in the layer between, in the barrier between those two layers. And we also see that happening when the water goes from a different medium like clay into loam. So if you go into a soil that is like more permeable into a one that is like less permeable, pardon me. So when you go from loam into clay, so instead of going into one that is like more permeable, you're trying to go into one that is less permeable. You will also see the water being held up at the barrier between those two layers. And all of that is because it takes a lot of energy for water to move vertically between different layers in the soil. This video still shows like some experiment with inserts, even gravel. It's possible to see that water comes like at an angle, 45-degree, but hardly penetrates it from top to bottom, which is what we have in our basins and just in our yard application. Pretty much like when we are saturating soil, that water needs to come from top to bottom. So how does our device helps to infiltrate that water? So iris infiltration adds a surface that saturated soil can pretty much bond to and allow that vertical movement that would be trapped into different soil layers. So this device is helping to move water from areas of like high concentration into areas of lower concentration. All of the water movement, it's important to say it still happens from particle to particle. So the device is not being like a conduit to water, and I'm going to share a little bit more about that later. But it is allowing soil to bond to the surface and water to bond to that soil particle, and then it's helping all of that to move like much faster. So in this illustration that you're seeing on the screen, you can see the action of like one device, but if you imagine that we have hundreds and even thousands of these installed into different applications, you can really see how you go from a region of like mounding and the standing water and lots of resistance to infiltrating water into the ground to an area that you now have better drainage and you have water being distributed both vertically and horizontally around the area that the devices is spread. So all of this is done while maintaining the ecological balance. I have a little bit more to share about that as well. But this is a very brief explanation of how our product works. Now, okay, I'm over it. So now let's talk about how this device, what it looks like. You got me curious. So this is a profile of what IRIS infiltration looks like. The device is really only like 1 inch and a quarter in diameter. And our larger applications, it's 2.5 inches in diameter. But as I mentioned before, these devices are installed in a system that will vary from 5 foot in length all the way to 60 feet. So they are always installed 2 to 3 feet below the ground surface. They are made of polyethylene, which is pretty much like a food grade polymer that does not leach any chemicals in the ground, and also has like a very great life if you consider installing them into the soil. So it's not a product that you will be looking into replacing for the next like 20, 30 years because of the material it's made of. Installation is made by a very compact and tailored machine that was designed for this application. I can share a little bit more about that with a video with all of you. Oopsie, why is my screen resisting that? So here's a video of that compact machine that I just mentioned, installing those devices. So this machine is remote controlled. You can see over here that the machine will dig like holes that are only about 2 to 3 feet deeper than those devices. Then the installers are going to place those devices into the hole. They'll push it down with an auger. That's what they're doing right now. And what you will also see is that there isn't quite a excavation process happening right here. We utilize this compaction auger, which is pretty much just compacting the soil around the devices, and there is a little bit of material that it's removed from the soil, and we utilize this to close the hole that it's on top of the device once it's pushed 2 to 3 feet below. So this little bit of material that it's removed is going to be compacted on top of the device. So by the time we leave the site, you can't barely tell that we've been there. Ooh, apologize. But I believe you have already seen the machine and the devices, so we should be good here. So this is what I have to share about the installation. Very compact machine, can go inside of basins, outside of basins, inside of yards, and it's very efficient in doing what it was designed to do. A little bit like I've already mentioned about the material, 100% polyethylene, nothing more added to it. So this device will not be leaching any chemicals, and it has like a very extended life once installed into the ground. As far as classification goes, it's usually classified by National EPA as a underground injection control well class 5, which is the same category where you would allocate your French drains. So it's a very low impact subsurface distribution system. Okay, so just to summarize a few of the features that we have mentioned so far, we have seen that this device and its installation is very like non-invasive, that there's a very small footprint. All of the area that it's available on top, on the land above this device, is available for use however you need. It's very scalable, and it is definitely environmentally safe. Now I'm going to cover our site evaluation, and that will help you understand a little bit more about how this product works and how we work around the product. So first and foremost, the first thing that we do is a environmental evaluation, which will guarantee that we are not installing these devices near any contamination zone, and we are not aiding any heavy chemicals to be reaching the groundwater, which is a very it's a very priceless resource that we share with everyone. So this is definitely the first thing that we always do. And after we check that site for environmental aspects, we do an overall evaluation of where that site is sitting. So our designs and our evaluation is always site specific. So it's hard to answer like, oh, how much would cost like a basin like this, or oh, how much does it increase for like this application. Everything is site specific because we're really interested in understanding what that device will do in that very specific location. So we take a look at the whole watershed. We make sure to understand all of the external factors that will be affecting that specific site. And then we drill in with all of the resources that we have to be able to provide like the best design that we can for that very specific application. So if we have soil borings available, if we have geotechnical reports, infiltration reports, anything that the client already have and share with us, that information will be utilized to make sure we have the best tool for what they are trying to use. Something else that it's important to mention when it comes to site evaluation and product like performance is to understand a few variables that will influence the performance. So one of the things that affect performance is of course time. So more devices will infiltrate a certain amount of water faster than fewer devices would, but nonetheless fewer devices would still be addressing like that overall amount of water, but in a delayed matter of time. So depending on how much time we have to work with for specific applications, and depending on the budget that we have for specific applications, we can design systems that are smaller or larger depending on how these variables will apply. And the other important thing that it's important to mention is the area, which also it's an important variable here. This usually only comes up when we're talking about underground reservoirs, when you're trying to put a very large amount of water in a reduced like footprint. But usually for basins, fields like sports fields, parks and recreation, area doesn't tend to be a limiting factor, mostly underground retention. But it's still important to say that like it's not magic, right? It's science. So there's only so much water that can move through the soil matrix in a certain matter of time. So making sure that you have enough area to move all of the water you're trying to move, it's also something important. So this is it for our site evaluation. I know it's very concise at this point, but I'm definitely open to questions at the end if anyone has any more questions. But now let's go to our frequently asked questions, because they also have a lot more to share about our device. So first one we always get, so this is not a conduit. Like, are you sure that you're not just like putting water into like the ground? How does it work then if it's not a conduit? Like, I thought I had got it before. So once again, we have performed several different tests and studies that have determined that this device is not acting as a conduit. So the image that you're seeing here, it's an experiment where this device is buried behind a acrylic lens. And much like the videos, like those saturation videos that we share in the beginning of this presentation, we are saturating this device to understand how the water is moving around it. So the entire time we understand, we see that the saturation front happens in the vicinity of the device, but at no given point we see any dripping water at the bottom. So all of the water movement is happening through soil particles that are in contact with the device, but not just dripping all the way to the bottom. And another experiment that we have conducted is the one that I'm mentioning here in this first paragraph. It's one where we have pretty much built like a little pool on top of those devices, and we have mixed a tracer in this water, bromide specifically. And so we have a certain concentration of this chemical and that water that is being discharged on top of a few of those devices, and then we are pumping water from the bottom with a shallow water table, and we are measuring the concentration of bromide, like on top and the one that's found on the bottom. And we have not found nearly the same concentration at the bottom of those devices that we found on top. And that is showing us that the soil is acting as a filtration factor, and also that water is not just shortcutting between the top of this device and the bottom of it. And more studies have happened as well, but for now I'm only going to share those two about being a conduit. But okay, I think I'm beginning to understand, like I'm still munching on those concepts, but what about groundwater quality and what about groundwater level? Like you're putting all of this water in the ground, and are you not changing the groundwater like elevation in a certain location? And the answer to that is also no, we're not. Many studies done about this as well. So what really happens is, if you're familiar with water movement in the ground, when it rains, usually our water table rises, and then it takes some time to recover to its baseline. With its device, it's gonna rise as much as it will, but that will happen faster. So instead of having like a delayed rise, like these devices will help it rise faster, and will also recover much faster. But we are not changing the elevation of the water table. And we have investigated this under shallow conditions, very shallow, and slightly deeper conditions, and that was always observed. And in terms of groundwater quality as well, every location where we have tested a control site and a test site, the results that we have tested from both were very comparable. So nothing was detected on a test site that had not been detected on the control site. So this device is not just helping to, like I said, just get stormwater and deliver it to lower layers, but the soil is still acting as a filtration component that is still breaking down, your basic elements as soil would be in a natural condition. So that's a very big plus for us, because we really care about the quality of the water that we are helping to infiltrate. So what about maintenance? Does this device require any maintenance after it's installed? And the answer to that is no, none, nothing. So once they're buried, like what we would do, right? Like unbury them. So once they're buried, that's it. They will just perform and they'll keep performing. So what are the images we're looking, and why are these images here? So this site that you're looking over here has been in operation since 2014. That's the reason that it's been here. 10 years have gone plus some, and never been maintained and still up and rolling. But what exactly are we looking? So this here is showing a test site and a control site 24 hours after a major flood that we have had here in Detroit. And these sites are only separated by a curb, like in Belle Isle. Like one is across the street from each other. This is shelter number 4, and this is shelter number 5, if you're familiar with Belle Isle. But this test site used to flood much worse than the control site, and hence it was chosen as a test. And after installing these devices, you can see the difference in drainage between one and another. So 10 years have gone by. No maintenance has been ever done here and in any other of our sites as well. As time goes by, product continues to perform. And as I move a little bit along here, you'll see how the time factor works a little bit too. So has this system ever been used to address like any road safety issues? Like, I'm curious as to what kind of applications like we can use it for. And the answer is yes, it has been used on roadside. This road right here, you can see this almost like a 90-degree like curve. And this is kind of like a rural area. It doesn't have like too many road access. So whenever they used to have any storm event higher than 0.3 inches, this area used to flood, and then they would have to like stop traffic. It was a real like nuisance for this community here. And after we installed these devices in that location, like they have not identified like any flood anymore. This is actually a letter from the Road Count Commissioner saying how pleased they were with this installation. Like, this was also a project installed in 2018 and has been operating to criteria since. No more floods. The road just simply has not been closed again after this have happened. Something else that we noticed is that this device definitely does really well for like soil moisture conditions, which is something that can really favor plant life. As our operators were driving by that road, they started noticing that like the trees by the road were looking like really good. And as we sent a drone just to investigate like if there was any noticeable difference in the trees that were closer to the device, that drone took a picture that is pretty much measuring how green those trees are. And you can see, which is an indication of plant health. And you can see that the trees that are sitting closer to the device installed on the edge of that road are definitely looking greener. That I believe is a consequence of like soil being moistured, and as you don't have flood anymore, like those plants' roots are not deprived of oxygen instead of like 2 or 3 weeks of water covering the soil. So I think that's a really good indicator that these devices do not have like any adverse effect on plant life. Okay, that's really cool, but I want to know the real deal. Like, does it really work in like heavy clays, like soils that are like not permeable at all? I'm talking about like clay, hard pans, like the hard stuff. Does it work? And the answer is yes, it does work on those cases as well. So the site that you're seeing here is in Georgia. Pretty much clay on top of clay all throughout the soil borings. And this area used to accumulate water for like 2 to 3 weeks after moderate rain events. And after we installed these devices over there, the site began like draining, like just draining, period, after installation. So in these little animations, you can see that even like heavier storm events than these devices were designed for are being accommodated in a matter of a extended period of time, which is what I mentioned before. So this site was designed for a 1-inch storm, but you will see here in this little animation that there's over like 5 inches of storm being back-to-back events adding up to 5 inches in 5 days, and all of that is still being drained and infiltrated. And we get those images because we usually have some trail cameras installed that give us time lapse. So it's a really neat way to see what's happening in our sites, and we track the rain events utilizing weather stations nearby, if not a rain sensor on site, which we sometimes have as well. And this is how we follow up with some specific applications. Okay, I like that. That seems to be moving in the right direction, but this is like much smaller than what I had envisioned. Like, have you tested these devices for great amount of water? I'm talking about large basins applications. Like, has it ever been used like that? And the answer is yes. These devices will also work for large volumes of water. So the data set that you're seeing here, it relates to a recharge basin in California. This basin has 4 acres in area, and it can fit about 20 acre feet of water in it. So before we installed our devices in there, you can see that the level of the water in that basin was always high. They measured it always above like 8 to 10 feet of water, and infiltration was like very, very little. So this was pretty much a recharge basin that was evaporating 70% of the water that they had in the basin. They were purchasing water to pretty much evaporate it. And once we installed our devices in that location, you can see that infiltration has increased like significantly. And now instead of evaporating 70% of the water, we are only evaporating 15%. So we actually quite switched that that proportion over there. And you can see here that the facility had monitored that basin for nearly like 7 years. So you have nearly 2,500 days of operation, and they have had 30 acre feet of accumulated infiltration compared to less than 2 years of operation, under 800 days, infiltrating more than 170 acre feet of water. So this has been like a significant increase in infiltration for a large recharge basin. All of the time we are dealing with this basin, and we are as much as we can, we always collect the data. We always understand the relationship between the variables that we are trying to measure, just to make sure we are providing the best solution for each specific application. This is the last question that we usually get a lot. What about slope stability? Like, I'm a little bit worried about erosion. Like, if I install those devices, I'm going to be drilling near my basin. Like, is that going to cause, like any erosion, any cracks or anything? And the answer to that is no. So in all of these basins that we have been installing these devices since 2014 that I can account for, we have never had any issues with slope stabilities as well. So this serpentine shaped basin that you're seeing here is the recharge basin that I just shared the data about. And because it's a serpentine shaped basin, you have water coming around, and you can see our little machine here installing 40-foot deep devices in those walls, and water coming all the way there, and no issue at all. Actually, I do have a theory that these devices actually help with erosion control. I believe that they behave kind of like tree roots, like holding the soil tight, because this basin here that you're seeing, it's another application where we have installed those devices. They have had some erosion issues on the north of that basin, but none where our devices are. So I don't have data in there, but I do have this sense that these devices might actually benefit that kind of application as well. But what I can say for sure is that we have never had any issues with wall stabilization or erosion where we have installed those devices. So that's most of what I wanted to share with you today. The last thing that I want to just blend and keep in your mind is the possibilities that we have with these devices. So there is so much that you can do with IRIS infiltration. If you think of any place where you have water on the surface and that you would benefit from putting it in the ground, it's an application that IRIS could help. So if you have any standing water issues, or if you're trying to reduce the footprint of a certain basin, or if you want to hop into that market of like water credits, like this is certainly a product that can help you in that aspect. And the last semi application that I'm going to share is about the compatibility of this device. Like I mentioned, because it's like so low impact, and the scale, not the scale, but uh, it doesn't it doesn't really, how do I say, it doesn't really spread, like all that much, like compared when you're doing a project with gray infrastructure. That makes it really compatible with different technology. So what I have here on the screen, I'm sharing an underground retention chamber being combined with those devices. So sometimes people will, when they don't have enough space to infiltrate water, they'll utilize those chambers, but it doesn't do you any good if the water enters the chamber and then has nowhere to go if you don't have drainage. Like if you have back-to-back storms and then you suddenly don't have your reservoir. So those devices are a great aid for that kind of project. This image that I'm sharing here is actually a underground retention facility that we have at Lawrence Tech University. So this is a 20 by 25 foot that is 6 feet deep, filled with engineered aggregate and covered with permeable pavement. So it's a parcel of the parking lot that it's been now reserved for infiltration. And so these devices are helping to make that reservoir available anytime like a storm event comes by. So if you think of like rain gardens, like bioswales, other like larger scale underground retention chambers, there's definitely a lot that you can combine this device to get a even bigger benefit from those best management practices. So I want to finalize this sharing again a little bit more about her features and benefits from IRIS infiltration. And I do want to mention like how scalable this device is. You really can go all the way from like backyard to recharge facilities. It has a really small footprint. It's really easy to combine it to other technologies. Really non-invasive, like you will not be having any ecological like disturbances with the addition of iris infiltration alone. And it has worked every time. Like we have not seen a case yet where this device has not worked within like proper design conditions. So this is what I had to share with all of you today. And now if anyone has any specific questions, I will be happy to take them.
That's a solid presentation, Lohayne. Like I've done a lot of conferences, and let me be the first to say that not all the presentations are created equal, right? So no offense to anybody out there, but your presentation was really solid. I was literally
Thank
trying to
you.
think of questions, right, to come up with, and the different applications, the small footprint, and you just kind of knocked them all down before I could even get to them. We don't have any questions right now in the comments, but now's the time. I know it seems like there's about 24, 25 of you that have made it this far with us. So if you have questions, feel free to pop them in the comments. And we'll wait on that for just a minute and give you a chance to do that if you have a question. Some other kind of housekeeping points while we're waiting on that is if you would like to get a PDH certificate for having attended today's presentation, please put in the comment PDH and how you want your name to appear on your certificate, and we will take care of that. If you're just totally against playing my game and putting your question in the comments, and you do have questions, You can, Lahaini, are you very active on LinkedIn? Would it be better if they just email their questions to info at
Yeah,
parjanaeng.com?
yeah.
Parjana,
Parjana ENG.
yeah, ENG, Parjana, ENG, PARJANAENG.com.
There we
Info
go.
at parjanaeng.com. If you have some questions or you'd like to follow up with Lahaini, if you have any if you I don't know, if you got a challenge on a project. I mean, this product. I mean, to me, it's neat because of the flexibility in footprint, right? I think that's a huge
Hmm.
upside, especially if you're in a situation and you've got some of the standing water situation that you're showing there, and you're
Hmm.
scratching your head like, how can we do this without being completely invasive? Let's see. We've got Sahil just asked, what a great product. Is there any consideration adjustments that occur when applied in winter climates? Do freeze thaw cycle impact performance?
Yeah, so, well, we're located right here in Michigan, right? So there's definitely a lot of like frost here. So the winter considerations will depend on your design goal. So if you're, let me be a little bit more clear with that. So like some people, they have flooding issues in the spring, and the spring is where they're concerned with the standing water, so that we have like some design considerations for that. Now, some people have a little bit of water that just makes enough ice that everybody slips through that, and then that's a different issue. So if you're having issues during winter itself, usually what we suggest is to work with a small underground retention chamber, and that will take just your peak volume, and that tiny bit of water that would be creating that ice layer is now contained inside of a reservoir, and then you don't have that ice issue anymore. But if your issue is more on the spring and when things are beginning to thaw, then you might not need that chamber. The devices alone might be able to do that. So it's been our experience in the past that where these devices are installed, that thawing process happens like a little bit faster, and it also helps to infiltrate that water a little bit faster. So the devices will be operating, of course, they will not operate at the same rate as it would in the summer, but your native condition will be improved by a lot. So we do have lots of applications where we have installed in the winter, but specific considerations depends on what kind of site we're talking about and what your goals are. Like I said, we usually take a good time to tailor like specific solutions for specific problems to make sure that you're getting the best out of your investment.
Awesome. So, Hill, I hope that answers your question. And then like we said before, if you have some follow up or if you have actual specific application that you need to sort out, please reach out to Lahaini. And again, the best way, info at parjanaeng.com. Kevin Kaufman had a question. And thank you, Sahil, for your question. Kevin asks, is Parjana Engineering comfortable designing IRIS infiltration systems ranging from 10,000 gallons per day up to a billion gallons per day? That's pretty big.
Yeah, I think that that's a very great question, and I think those devices are pretty scalable. I would be totally comfortable with that. We would be getting into that conversation about area, right? Like how much area we have available to infiltrate these billions of gallons, but totally. And a fun fact, actually, is that we keep track of our devices and the areas that they are influencing and all of that. And we have actually, in the history of our company, infiltrated more than 1 billion gallons of water. So We have aided in the infiltration of over 1 billion gallons of water with all of those devices spread across the United States. So we're way above that mark actually. So yes, I think we would be very comfortable doing that. Again, just an eye on the uh, allocated
The
like
area, right?
area,
Yeah,
and
yeah.
make sure you
A
have
billion
water to infiltrate
right?
too.
A billion gallons
Yeah,
coming down like you're right here on my desk
source
would
of
probably
water
be tough,
also.
right?
If you have available water to do all of that, that's also an important aspect of it.
Right, right, right. All right. Well, let's see where we are in time. We still have a few minutes. Thank you. I see the PDHs coming through. Please give me a little time to get those sorted over the next few days, and we'll get them out to you. They will be coming out from me, from my team at Digital Stormwater. Parjana Engineering is one of our clients, and so we will facilitate those PDHs and get those out to you as soon as possible. All right, last chance. Any final? If there's not any final questions, then I just like to extend another thank you to you, Lohayne, for taking the time today. This presentation, if you ever wanted to share it with anybody, those that are still with us, if you wanted to share it with us, it will eventually end up on the Stormwater World YouTube channel, and it'll be tagged out to where you can find it through search and share it with your teams. And I appreciate everybody that came and listened. If you have a certain topic that you would like to see us do on a future Stormwater Live, please drop it in the comments. Or if you'd like to present yourself, you can drop that in the comments, or you can reach me at ty@digitalstormwater.com. And with that, thank you so much, Lohayne, and we're going to let everybody get back to their lunch.
Sounds good. Thank you for your opportunity. You all have a great afternoon.
Oh, and happy holidays, Merry Christmas, Happy New Year's. I can't believe Christmas is in a week, so I almost
Yep.
forgot. So happy holidays, everyone that's still with us, and be safe out there. So thanks a lot.
Sounds good. Thank you. Happy holidays.